The ice and rain protection system enables operation in icing conditions and heavy rain. For anti-icing, critical areas of the aircraft are protected by hot air or electrical heating. The pneumatic system provides hot air for the anti-icing of the 3 outboard leading edge slats of each wing. Each engine air intake is anti-iced by an independent air bleed from the high-pressure compressor. The air is supplied through the engine anti-ice valve. Note, in the event of an electrical power supply failure, this valve will automatically open. Electrical heating is provided for windshield anti-icing and cockpit side window defogging, the angle of attack AOA probes, the total air temperature TAT probes, the pitot probes, and the static ports. When the electrical system is powered, the water waste drain masts are also electrically heated. Note, on the ground, the heat is reduced to prevent injury to ground personnel. The ice detection system, if installed, consists of 2 separate ice detectors located on the forward lower section of the fuselage. An external visual ice indicator with an integrated light is installed between the 2 windshields. All the ice and rain protection controls are located on the overhead panel. The crew manages wing and engine anti-ice valves through the anti-ice control panel, all the electrical heating system by the probe window heat push-button switch. Memos associated with anti-ice operation are presented on the engine warning display memo area. To improve visibility in rainy conditions, the flight crew can spray a rain repellent liquid. Separate push buttons control the application of the rain repellent on each side of the windshield. Electric wipers are provided for the windshields. They are operated at slow or fast speed through the wiper selector located on the wiper panels. The maximum speed with the wipers in use is 230 knots. During the walk-around, you will verify the condition of all the pitot, AOA and TAT probes. You will also check that all the static ports are clear and the covers are removed. In cold weather conditions, there are additional procedures for exterior inspection and ground de-icing, anti-icing. As part of the cockpit preparation phase, you should check that the wipers are off and the probe window heat push-button switch is set to auto. Note, when in the auto position, the probes and windows are heated automatically after starting the first engine. Today, your takeoff is in icing conditions, so let's see what you have to know. Potential icing conditions are defined as outside air temperature below 10 degrees Celsius, visible moisture in the air. Note, As with any anti-ice system, you should turn the system on without waiting for a visible ice build-up. The engines are running. The automatic function of the probe window heat system means that on the ground, the probes, TAT accepted, and the cockpit side windows are heated. The windshield heating operates at low power. Note, you can also defog, de-ice the windows manually prior to engine start by pushing the probe window heat push-button switch to the on position. Because you are in potential icing conditions, the engine anti-ice system must be selected on. Select the Engine 1 anti-ice. Notice that the amber fault light in the Engine 1 anti-ice push-button switch illuminates momentarily during the valve transit. As soon as one engine anti-ice push-button switch is set to on, the engine anti-ice memo appears in green on the engine warning display. The ignition memo appears in green, indicating that continuous ignition is automatically selected for the engines. The idle N1 is automatically increased to give better protection against flameout. N1 limit, amber tick, is automatically reduced because air from the engines is taken for anti-icing. Continue by selecting the Engine 2 anti-ice. Both engine air intakes are now being anti-iced. Note, the fan blades are not anti-iced. If significant engine vibration occurs due to ice accumulation on the blades, the engine should be accelerated to 70% N1 minimum for approximately 15 seconds prior to higher thrust operation. As an added precaution, we will use wing anti-icing. The wing anti-ice push-button switch controls the wing anti-ice system on both wings simultaneously. Note, use of APU bleed for wing anti-icing is not permitted. Please select Wing Anti-Ice. Notice that the blue light comes on, the fault light in the wing anti-ice push-button switch illuminates amber momentarily during the valve transit, the wing anti-ice memo appears on the engine warning display, and the idle N1 is automatically increased. We have called the ECAM bleed page for you. Observe that the anti-ice white indications are displayed, meaning that the wing anti-ice push-button switch has been set to on, and the green triangles are displayed, indicating that the wing anti-ice valves are open. Observe that 30 seconds after the wing anti-ice push-button switch has been set to on, the wing anti-ice valve indications disappear. This is because the wing anti-ice valves close automatically to prevent an overheat of the slats. This is the ground test sequence. At liftoff, the valves will reopen automatically and the slats will be heated again. Note, use caution when taxiing with engine anti-icing on, because ground idle is increased. You are now in cruise, clear of icing conditions. If you do not expect the conditions to change, anti-icing systems should be switched off. Note: if the ice detection system is installed, an ice not detected memo indicates that no ice has been detected for approximately 3 minutes or more. We have called the ECAM bleed page for you. First, switch the wing anti-ice off. Observe all the wing anti-ice indications have disappeared on the ECAM bleed page. Continue by switching off the engine anti-ice systems. First, switch engine 1 anti-ice off. Now switch engine 2 anti-ice off. During climb or cruise, the anti-ice systems may also be switched off when the SAT is below -40 degrees Celsius, even if there is visible moisture. We are about to commence the descent. Because potential icing conditions are expected, the engine anti-ice system is switched on prior to starting the descent, even if the SAT is below -40 degrees Celsius. We will switch the engine anti-ice on for you. You are now in descent. The engine anti-ice system is on. You observe ice accretion on the visual ice indicator. So that you can observe the indications, we have called the ECAM bleed page for you. Switch the wing anti-ice on. Observe that the wing anti-ice indications are displayed on the ECAM bleed page. The wing anti-ice memo appears on the engine warning display. Note: because the engine idle speed is increased when the anti-ice system is used, the descent path angle is reduced. You are now taxiing to the gate. The wing anti-ice valves have closed automatically, and the engine anti-ice is still on. Turn the wing anti-ice off. As the approach was made in icing conditions, do not retract the flaps and slats until after engine shutdown. Wait until they have been checked to ensure that they are clear of obstructing ice. Note: 1. During extended ground idle operation, periodic engine run-up, 45% recommended, may be performed to remove any ice from the fan blades. 2. For ground operations in heavy rain, refer to your FCOM. This is a demonstration of an in-flight failure of the left windshield heating system. You are currently flying at your cruise level. Everything is normal. On the engine warning display, read the title of the failure. In this example, the blue line advises you to avoid icing conditions. Notice that no system page is called. Having noted the advice, and after review and confirmation from the pilot flying, clear anti-ice. The status page is now displayed and reminds you to avoid icing conditions. The inoperative system is the left windshield heating. After review and confirmation from the pilot flying, clear status. ECAM action completed. Let's continue with an in-flight captain's pitot heating failure. You are still in cruise. Everything is back to normal. On the engine warning display, read the title of the failure. This time the captain's pitot probe heating is not operating. This could lead to ice build-up on the captain's pitot, causing incorrect speed information. To ensure valid information to the captain's instruments, the air data source should be changed. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. By selecting Captain 3 on the Air Data Selector, ADR 3 replaces ADR 1 to provide valid data to the captain's instruments. Note: air data switching should not be selected to Captain 3 if ADR 3 is not available. After review and confirmation from the pilot flying, clear anti-ice. On the engine warning display, the memo message switching panel is displayed to remind you that the captain's ADR has been switched. The status page is displayed. The inoperative system is the captain's pitot heating. After review and confirmation from the pilot flying, clear status. ECAM action completed. You are continuing the flight and everything is back to normal. On the engine warning display, read the title of the message. Ice has been detected by at least one detector. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. Continue ECAM action. After review and confirmation from the pilot flying, clear anti-ice. You are now in heavy icing conditions. On the engine warning display, read the title of the message. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. On the engine warning display, read the title of the failure. The ECAM caution Wing Anti-Ice System Fault appears, meaning that at least one wing anti-ice valve has not opened after switching the system on. Notice the ECAM bleed page is called automatically. Before applying the ECAM actions, you should clear the first message. After review and confirmation from the pilot flying, clear anti-ice. On the ECAM bleed page, there is no green arrow on the left side, meaning that the left wing anti-ice valve is not open. Observe that the fault light in the wing anti-ice push-button switch remains illuminated. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. On the system page, all wing anti-ice indications have disappeared, meaning that wing anti-icing is no longer operating. The ECAM advises you to avoid icing conditions. After review and confirmation from the pilot flying, clear wing anti-ice. The status page is called. The message Avoid icing conditions is displayed, The inoperative system is the wing anti-ice. After review and confirmation from the pilot flying, clear status. ECAM action completed. You are in cruise. The entire anti-ice system is operating, and you want to switch off the wing anti-ice system. Please do it now. Observe that, on the engine warning display, the ECAM caution wing anti-ice left valve open appears, meaning that the valve is stuck open. On the ECAM bleed page, the green arrow is still displayed, indicating that the valve has remained open. On the anti-ice panel, the amber fault light illuminates, because there is a disagreement between the selected and actual position of the valve. According to the indications, wing anti-icing can be selected on for both wings, if required, but is continuously on the left side. There is a thrust penalty, shown by the message on the engine warning display. After review and confirmation from the pilot flying, clear wing anti-ice. The message thrust limb penalty is also displayed on the status page. After review and confirmation from the pilot flying, clear status. ECAM action completed. However, the fault remains. Let's see the effect of the fault after landing. An automatic recall of the failure has occurred, with a new procedure because you are now on the ground. The ECAM action is to switch off engine 1 bleed. This is to avoid overheating the left wing by isolating the air supply from the wing anti-ice system. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. The engine 1 bleed valve is closed, as shown by the white off light illuminated on the corresponding push-button switch, and the indications on the ECAM bleed page. Note, as the left wing is affected, the APU bleed should not be used. No further action is required. After review and confirmation from the pilot flying, clear wing anti-ice. The status page is called repeating the message you had on the engine warning display. The inoperative systems are Pack 1 and Engine 1 bleed. After review and confirmation from the pilot flying, clear status. ECAM action completed.